Assalamualaikum and a very good day, class. One of your question asked me about example 1.3, which is at page 11. Okay, this is about Taylor series expansion. So, class, in this question, you need to approximate the function of, we have function y equal to cos x by using Taylor series expansion about x equal to 0, and then you need to use here p1x, p3x, and also p5x. And in each of these, you need to approximate the values at x equal to pi over 12 and also pi over 3. How to do this? First, you need to understand the information from the question. In this question, give to us y equal to cos x. What does it mean by this y? This y you can also write it as your fx, which is fx in this case equal to cos x. When mentioned here about x equal to 0, means that in Taylor series it's referred to the x naught. So in our case, x naught here equal to 0. And all these p, actually you have to base on the Taylor series formula. That is, we need to find here P1, P3, P5 by using P and Taylor series formula. So class, if you recall back the lecture, okay, the video from the lecture here, P and X, general form of Taylor series is given by Fx naught plus x minus x naught f prime x naught plus x minus x naught to the power of 2 divided by 2 f double prime x naught plus x minus x naught to the power of 3 divided by 3 factorial. And how to find the 3 factorial? You can use your calculator, f triple prime x naught, and then plus x minus x naught to the power of 4 divided by 4 factorial, f4, which is here f, you need to differentiate function 4 times x naught, and then plus x minus x naught to the power of 5 divided by 5 factorial. Here f to the power of it, to the power of it here refer to the derivative. You have to differentiate 5 times, okay, for that x. Here x naught plus dot. Actually, this is n, so up to the x minus x naught to the power of n, which is divided by n for factorial, and then differentiate function n times x naught. In this case, we have the information our x naught equal to 0, and this is our fx. Means that you have to base on this fx. If you refer that, you need to find here the truncation of the Taylor series for P1, P3, and P5. So that in this case, you need to have, okay, the first derivative. If for this P1x, it is up to this derivative. If we consider P3, so you need to add 2 more terms here. So it will be up to this one. And then when we consider P5 here, so our term, it is up to a fifth derivative. In this case, class, okay, the first step here, you need to know how many times you need to differentiate function. If you see here, for P1, we need to differentiate 1. For P3, you need to find second, and also you need to find third derivative. For P5, you need to find fourth and fifth derivative. So to make it easy, we form here in terms of table, that is our n should be 0, 1, 2, 3, 4 up to 5 because it is up to fifth derivative. And here we find the derivative of our function, and then we find the value of the derivative when our x not equal to, in our case, you know it is about x equal to 0. This about is a keyword, give us that x not equal to 0. So here x not equal to 0. We have simple function. When n 0 means that you use this cos x. So we will not differentiate function. We have original function. So when n 0 means that it is cos x. When here n equal to 1, so you need to find f prime x. Okay, this is our, okay, I write this one as y. So for the next one, differentiate 1, differentiate this one 1, you got negative sign x. And then when n equal to 2, you have to find second derivative. So differentiate this one, you will got actually positive cos, but this has negative, so negative cos x. And then differentiate again third times. Okay, y triple prime here will have negative sine x, means that equal to sine x. And next, for the 4, n equal to 4, so you need to find fourth derivative, which is differentiate this one, you got cos x. And for the fifth derivative, y, for the fifth derivative, you have to differentiate this one more time, you got negative sine x. Okay, so class, when this x, okay, when this x we replace with this x not equal to 0, so you need to find y at 0 here, means that cos 0, you use your calculator, but make sure that it is in radian mode, so you got here 1. And then for the n equal to 1, okay, y prime, substitute here. Okay, substitute our our x here with 0. So we'll got equal to negative sine 0, which is use your calculator, you got 0. And then again, the same thing we did for y double prime, y triple prime, and so on. So y double prime 0, we will have here negative cos 0, that is equal to, use your calculator, cos 0 is 1, negative, so it is negative 1. Y triple prime 0, it is equal to sine 0, so equal to 0. Y to the power of 4, sorry, 4 times derivative, okay, we got here equal to cos 0, so equal to 1. And then y, for the fifth derivative, it is equal to negative sine 0. Use your calculator, you got 0. So class, based on this, what we did actually, after you form this table and you find its derivative, and then you find the value when the derivative is about x equal to 0, step number 2, we need to write our Taylor series form. Number 2, we write our Taylor series form. We write in general form P5x first, then we will truncate. In this case, our Taylor series form for, is given by, remember we have, I write again, fx naught plus x minus x naught, f prime x naught, plus x minus x naught to the power of 2 divided by 2, f double prime x naught, plus x minus x naught to the power of 3 divided by 3, f triple prime x naught, plus x minus x naught to the power of 4 divided by 4 factorial, sorry class, here 3 factorial, f fourth derivative of x naught, and then x minus x naught to the power of 5 divided by 5 factorial, fifth derivative of x naught. Okay, it is up to fifth derivative here. And then when we substitute what we did, okay, what we got in this function, you can see 1, 0, negative 1, 0, 1, 0. We substitute fx naught is 1 plus x, okay, x, we make it general first, okay, minus 0, so minus 0, f prime 0 is actually, you got the first derivative, when you substitute with x not equal to 0, you got 0, and then plus x minus x naught to the power of 2 divided by 2, f double prime is f double prime 0, which is y double prime 0 is given by negative 1, and then plus here x minus 0 to the power of 3 divided by 3 factorial, f triple prime 0, it is 0, and then plus here x minus 0 to the power of 4 divided by 4 factorial, f, which is the fourth derivative of x naught equal to 0, it is, you need to times with 1. This is based on previous table. And then plus here, x minus x naught, x minus 0 divided by 5. This one 5 divided by 5 factorial to the power of 5. And then for the fifth derivative, it is 0. So what we did here, we'll have 1 plus x naught, 1 plus x times 0. This one times 0. Okay, plus this one become minus, because we got here minus x to the power of 2 divided by 2, plus here x to the power of 3 divided by 3 factorial times 0. Okay, plus here x to the power of 4 divided by 4 factorial times 1. Okay, and then plus x to the power of 5 divided by 5 factorial, which is times 0. So class, when we want to compute here P1, okay, P1x, it means that we just consider up to the first derivative. First derivative here is given up to this one, right? So the term is up to this, which is it is equal to 1, just equal to 1, okay? And then when we want to find P3x, it will be equal to, you need to consider up to third derivative. Third derivative means that we remain in our TaylorSeries up to this term. So this term is given by up to this one. So you will have your 1 minus x to the power of 2. This one is 0. So this one will be 0. And then for the P5x, you need to remain in your term up to all here, up to the fifth derivative. So you will have here, okay, we consider all this, that is 1 minus x to the power of 2 divided by 2, which is plus here. This one 0, right? This one 0, and also this one 0, so just plus x to the power of 4 divided by 4 factorial. Okay, so next, the question asks you to compute actually for x, okay, the function for x equal to our x equal to pi over 12 and also x equal to pi over 3. So that we need to substitute these two x in our P1, P3 and also P5. Means that class, for the next step number 3, what we need to do is, okay, to make it easy, we form the equation. We form a table. So here is our TaylorSeries. Okay, TaylorSeries. So the first one is P1x. Next is P2x. The next one is P5x. This one is P3x. So class P1x, remember previously it is equal to 1. P2x equal to 1 minus x to the power of 2 divided by 2. P5x equal to 1 minus x to the power of 2 divided by 2 plus x to the power of 4 divided by 4 factorial. And then based on this, we need to find this all P for the first one, x equal to pi over 12, and the next one is for x equal to pi over 3. When x here, okay, we substitute with pi over 12, understood it is equal to 1, okay, because this any value of x will give P1 equal to 1. Same with this x equal to pi over 3. And then when we substitute x equal to pi over 3 in pi over 12 in the P3, we'll got here for this one 1 minus this x class. You substitute with this value. So pi over 12 to the power of 2 divided by 2, you'll got here the answer equal to 0.9657. You can write it up to 4 decimal places. And then class, when we substitute with pi over 3 in this x, we'll have here 1 minus pi over 3 to the power of 2 divided by 2, which is here equal to 0.4517. Okay. And then if I consider for P5, I substitute x here equal to pi over 12. I will have 1 minus pi over 12 to the power of 2 divided by 2 plus pi over 12 to the power of 4 divided by 4 factorial. Remember class, this one is 4 factorial. Use your calculator by using 4 factorial. It is not 4. Okay. So here, when you use your calculator to compute this one, you'll got 0.9659. You can use up to 4 decimal places. And then class, for this one, we substitute our x here with pi over 3. We've got 1 minus pi over 3 to the power of 2 divided by 2 plus pi over 3 to the power of 4 divided by 4 factorial. You use your calculator, you'll got the answer 0.5018. Means that this table gives us the answer of the approximate function, okay, the approximate function of y equal to cos x at about x equal to 0, that is here x not equal to 0, for P1 5 over 12, P1 5 over 3, P3 5 over 12, because the question asks you to approximate function at these 2x. And then P3 pi over x, pi over 3, and also P5 pi over 12, and P5 pi over 3. So the answer is given in this table. This is how, class, you can use TaylorSeries function, TaylorSeries expansion to approximate the function. If you still have a problem, please PM me so that I can actually keep all this as a part of the question in our discussion during class hour. Thank you, class, for your attention. See you.